Hello, and welcome to another video of tutoring with Leah Cremona. So to convert grams to moles, you need to know the chemical formula for the compound, because then you need to find the molar mass of that compound, which you will use in order to find the number of moles. The moles can be found by dividing the grams that are given, or mass, by the molar mass. And remember, the molar mass is the number of grams of that compound in 1 mole. So the first step is to have the chemical formula. After that, you will find the molar mass of that compound, which will be counted as some number of grams per 1 mole. And then you calculate the number of moles by using this formula. So for the first example, a certain number of grams will be given. Let's say we have 35 grams of oxygen gas. And we want to know the number of moles in 35 grams of oxygen gas. So the number of moles is the question. As we can see here, the chemical formula for oxygen gas is already given. Step number 1 is complete. Now, the next step is to find the molar mass. So the molar mass of oxygen. So what we do there is we find oxygen on the periodic table, and here you can see oxygen has a mass number of 16 grams per mole. So oxygen is 16 grams per 1 mole. However, as we see by the subscript 2, we have 2 atoms of oxygen, which means we need to multiply 16 by 2. And this will give us the molar mass of oxygen gas. 16 times 2 is 32 grams per mole. And this is the molar mass for oxygen gas. Now, we need to find the number of moles by using this formula. The number of moles is equal to the grams that were given in the question, so 35 grams, divided by the molar mass, which is right here, 32. So 35 divided by 32 is 1.09 moles. We can also find this by multiplying the units and canceling out grams. The way this would work is that we have 32 grams per mole, and we also have the given amount, 35 grams. Now, what we want to do is cancel out grams so that we can be left with the unit of moles, which we're looking for. In multiplication, we are allowed to cancel out units when one is on the top and one is on the bottom. So we need to have grams on one level and the other grams on the other level so we can cancel them out. So here, 35 grams times, and because we want the gram units on different levels, one has to be on top, one has to be on the bottom, we know that 32 grams can be in the denominator and moles can be on the top. And this is for 1 mole. So now we can cancel out these units. Grams is canceled out, which leaves us with 35 divided by 32 moles, which is the same answer as here. We can also find this answer by using proportions. So in this case, we need two fractions separated by an equal sign. So what we can say is that 32 grams is in 1 mole, and 35 grams is in an unknown number of moles, so we can call the unknown number of moles x. So here, 32 grams is 1 mole, and 35 grams is an unknown number of moles. Here, we can then cross-multiply. 32 times x is 32x, and 35 times 1 is 35. Here it's just cross-multiplication. And solving for x, we divide both sides by 32, so that 32 can cancel out on the left side, which leaves us with 35 over 32, which is the same answer as we got before. Example number 2. If there are 150 grams of aluminum bromide, how many moles is this? As before, we remember our steps. We need the chemical formula of aluminum bromide. Looking at the periodic table, once more, aluminum is represented by Al, and bromide is here, represented by Br. Now, because the ion charge for aluminum is +3, and the ion charge for bromine is -1, we know that we have to have a subscript of 3 for bromine here, because we need the charge of the entire compound to be 0. So we know that if we add 3, +3, plus -1 times 3, because we have 3 bromides, we have 3 minus 3, which is 0. If I had only written aluminum and 1 bromine, 1 of each, I would have had a charge of +3 minus 1, which would be +2, which is not 0. So this cannot be. Now, once we have found the chemical formula for this compound, we need to find its molar mass. Once again, looking at the periodic table, we can see here that aluminum is 26.98 grams per mole. And bromine is 79.9 grams per mole. Now, because we have 3 bromines, we need to multiply this value by 3 so that we can calculate the molar mass for 3 bromines. (79.9) times 3 is 239.7 grams per mole. Added together, these two values are 266.68 grams per mole. This is the molar mass of the compound. Now, our next step was to find the number of moles. And we know that the number of moles is equal to the given mass divided by the molar mass. Plugging those numbers in, the given mass was 150 grams. And we divide that by the molar mass, which is 266.68 grams. The answer here is 0.56 moles, rounded to the nearest hundredth. Example 3. If there are 1.7 grams of sodium carbonate, how many moles is this? As before, our first step is to find the chemical formula for sodium carbonate. We know from the periodic table that sodium is represented by Na, and carbonate is a polyatomic ion represented by CO3 and has a -2 charge. Now, as before, the entire compound charge must be equal to 0. So right now, we know that one sodium has a +1 charge, and one carbonate ion has a -2 charge. So if we put one sodium and one carbonate together, we would have a total charge of +1 minus 2, which is -1, which isn't 0. So this cannot be. We need to have 2 sodiums in order for the entire compound to have a neutral charge. We show that there are 2 sodiums by putting a 2 as a subscript for Na. here is the chemical formula for sodium carbonate. Now, if we double check our charges, we have two positive 1s, so 2 times 1, plus a negative 2, which equals 2 times 1 is 2, plus negative 2, or minus 2, is indeed 0. So we know that this is the chemical formula for sodium carbonate. Next, we must find the molar mass of this compound. Sodium has a mass number of 22.99 grams per mole. Now, as we see here, there is a 2. We must multiply this value by 2 to yield the molar mass for 2 sodiums. And we will calculate that later. Here we have 1 carbon, and carbon has a mass number of 12.01 grams per mole. We only have 1 carbon atom, so we just leave the number here as it is. For oxygen, we have a mass number of 16 grams per mole. However, we see a subscript 3 that applies only to oxygen, so we know that we must multiply 16 times 3, which gives us this. Okay, 16 times 3 is 48 grams per mole. 22.99 times 2 is 45.98, and here we just keep this number as it is, 12.01 grams per mole. Now we add all of these 3 values up. The molar mass of sodium carbonate is 105.99 grams per mole. And finally, the third step is to find the number of moles using the equation. So the mass that's given divided by the molar mass. Plugging the numbers in, the given mass was 1.7 grams, and the molar mass is 105.99 grams per mole. The answer here is 0.02 moles rounded to the nearest hundredth. If there are 201 grams of barium fluoride, how many moles is this? Here, the problem is made slightly easier because the chemical formula is already given. Now, skipping to the second step, we need to find the molar mass of barium fluoride. Barium has a mass number of 137.33 grams per mole, and fluorine has a mass number of 19 grams per mole. Now, because there are 2 fluorines, we must multiply 19 times 2 to give us the mass of 2 atoms of fluorine. Now, 19 times 2 is 38 grams per mole, and we know that we have to add 137.33 plus 38 to yield the molar mass of barium fluoride. The molar mass of barium fluoride is 175.33 grams per mole. Now we get to find the number of moles, which we know from before is the given mass divided by the molar mass. Plugging the numbers in, the given mass was 201, and the molar mass was 175.33 grams per mole. The answer here is 1.15 moles. Thank you so much for watching this video. Remember to subscribe if you're new. And please let me know in the comments if you found this video helpful or if you have a different way that you solve these types of questions.